Okay, well, I'm going to go ahead and construct this picture. Now the picture gets a little bit complicated, maybe a little bit messy, and it was so bad when I did it in class that I just abandoned it. I mean, we got a jumble of lines, and I didn't choose to use that picture here. So, here's our x, y, z. Now, the point 2, 3 in the xy plane is just at x equals 1, 2, y equals 1, 2, 3. That's going to be this point, and this point is 2, 3, 0. We can evaluate f at this point, and we get 2/3. So now we can say, okay, well, our point on the graph of f of xy versus xy is going to be here. So this is our point, and any place I label this, it's going to be risky because I'm going to try to sketch these planes, and I'll try to do this a little better than I did before. So I'll just say here's our point 2, 3, 2/3. Now we know that in the plane where x equals 2, this thing has a graph that looks like this, and it has a tangent line and a tangent vector. So let's see if we can incorporate that into this picture. Now I don't really need the negative, the part of this particular y plane parallel to the yz plane that lies to the left of this point. So unlike what I did in class, I'm simply going to sketch this, and I think I'm going to use two different colors, neither of them white. I'll use blue here. Okay, so right there's a line that's in this plane, and right here is a line that's in this plane. This line being parallel to the z-axis, this line being parallel to the y-axis. And then we can have this line parallel to the x-axis. Now I'm going to sketch just the right-hand half of this plane by simply drawing, first of all, a boundary of that half of the plane. And then I'll just draw a few horizontal lines and a few, I drew too many horizontal and vertical lines before, but a few vertical lines to make this kind of look like a grid and maybe a half plane. Then I'm going to make the boundaries a little heavier, and I'm going to make this boundary a little heavier, but of course this boundary corresponds to our z-axis. And maybe I'll make this boundary a little heavier and put an arrow on it to indicate that this would be the y-axis for this picture. Then at the point 2, 3, 0, well, I've only got the part of the plane that goes from here over. So, because of course here's the point 2, 3, so right here's my graph point, and I'm going to say, okay, well, now I've got this curve here. It's got a tangent line. I drew the tangent line in purple, so I'll imitate what I have up here. I'll draw the same tangent line. It's in purple. Doesn't have to stop at the x-axis or the y-axis in this case. And I'll draw my vector in red, which is kind of hard to distinguish from purple when I mix the chalk lines. This vector then is the vector j minus 2/9 k. I probably don't have the vector of the right size, although I'm probably not that far off just by dumb luck. This is the vector j minus 2/9 k. Now I'm going to draw part of the xz plane. I'll draw that in green. And of course, this is in the plane where y equals 3. The plane y equals 3, well, right here is an axis that will correspond to an x-type axis. I don't want to label it x because this is already labeled x. And my vertical line will now correspond to something very much like a y-axis. And it coincides with this blue line. I've drawn them side by side, but they're understood to coincide. And from the point 2, 3, I've got to draw a line with a slope of 1/3. So slope of 1/3, if I move from here to here, okay, a rectangle would look like something like this in this plane. And if I go up by 1/3 of this distance, I've got to go up to about here. So my line, that's not a very straight line. Looking at a bad angle, I had to fudge it. This is understood to be a straight line, and it's got a vector along it. And this vector is the vector I plus 1/3 k. Now we want to embed that in a plane, so I want to kind of indicate a plane parallel to the xz plane, but not in the xz plane. Okay, I actually maybe want to take it down to here, so I can draw some lines here to kind of indicate this plane. So it's like back of the room, side of the room, back wall, side wall. This vector is along the back wall, this vector is along the side wall, and now, furthermore, their cross product is going to be normal to the plane, and kind of lost my arrow indicating where the point 2, 3, 2/3 is, but right here it is, where these two curves, you know, the curve in the plane parallel to the YZ plane here, the curve which is just a straight line parallel to the XZ plane, in the plane parallel to the XZ plane here. So now I've got the two vectors. Hopefully this gives you a reasonable depiction of how these two graphs combine to show you what the behavior is at this particular point.